Hello and welcome to this walkthrough video of the Edexcel GCSE Computer Science Paper 2, which is called Application of Computational Thinking. Now this is the on-screen exam. What you're seeing right now actually you wouldn't get on screen actually, you'd get this printed. This is the front page of your exam booklet, but all of the rest of it is done on my computer as you are programming. So I'm going to go through it and answer it. I haven't seen the mark scheme yet. I'm going to do it as I would approach it if I was sat in this exam, and hopefully you'll pick up some advice and techniques and so on. Now I would say at the time of recording, this is one of the only papers available to you to practice, and because the on-screen exam is a bit of an unknown for every single person, it's important you've practiced this exam in as real conditions as possible before you watch this video, before you do anything else. Okay, so if you're watching this 10 years down the line, this might not be relevant, but I'd really almost recommend you don't watch this until you've done it or you've had a good go. You know, my fear is if you've got a mock coming up and you sort of know they're going to use this paper, well, you watching this video or doing it yourself or looking at the mark scheme would be a mistake, because actually having as much real practice as you can before the actual exam is going to be really beneficial. Partly because this is a long exam, it's 2 hours long, and so a lot of it is going to be stamina and keeping your head and, you know, not spending too long. Despite the long time, it's easy to overcompensate and spend incredibly long on each question, and you might run out of time. So before I get going actually answering this myself, let's just go through some of the key details relevant to this exam. Now first of all, this is a sample, which is partly why I kind of gave that long disclaimer about trying to do it for real. The mark scheme is on the website, and I'll link the mark scheme below. Because it's a sample, no one actually sat this for real, and so there are no grade boundaries at the time of recording, although you can look up last year's grade boundaries if you want to, just for a guide. Now, the way this works is, of course, you're doing it on a computer at school, and it will have your IDE installed. I'm going to use Python idle because I think it's the simplest and is perfectly adequate. You might have a slightly more fancy one, which is fine. Importantly, you've got to be able to make sure it shows line numbers. So learn how to do that before you start. Idle versions have changed a little bit recently, but if you go to one of these options, you can click show line numbers and it'll show on the left. Now, you're also going to have inside your shared area on this computer a few things. You're going to have a folder called student coding, which you shouldn't open until, or shouldn't look inside before you start the actual exam, because this has the 6 code files and possibly some text files occasionally, which are going to be used in the exam. You'll also either have or will create a completed coding folder, which is where your solutions will go and what gets submitted to the examiner. And there'll also be a PDF, which is the programming language subset, which I've opened in another screen, which, as you should have seen before, contains all of the Python constructs needed to answer all of the questions. Now, there are 15 pages. Some of the pages towards the end in particular are very confusing to read, including for me, first time I read it or first time I skim read it. So make sure you've studied this. You may not need it. Ideally, you'll be confident enough that you can walk in and just do the questions, but it's a nice reference to have because you can't use the internet. This will be your only reference inside the exam. So you shouldn't be looking at it for the first time as you're scrambling to find a particular function in the real test. Now, this paper is out of 75 marks, as was paper 1, the difference being you've got a lot more time in paper 2. So if you are spending about a minute per mark, you've got 45 minutes spare at the end to check. Now, for many people that will be fanciful to say that. It will often take a lot longer because you are having to debug and design these programs and so on, but it's worth being aware that you may have some lax time if you are strict with how long you're spending on each question. Now, it does give you some fairly generic advice at the end here about obviously reading each question, saving your work regularly and checking your answers if you've got time. Obvious stuff. I think my second one is going to be really, really important, saving your work regularly. The only things which are going to get marked are inside the completed coding folder you are going to submit. So organization is really, really important. And I'll show you how to do this once we see the first question. So let's do that. Let's have a look at what the first question was. Did not track across. Brilliant. Okay, so does hopefully give you a suggested amount of time to spend. We can try and follow this. I may waffle too much to meet that. So we've got a program which simulates the roll of a dice. The program uses a random number generator to create a random integer between 1 and 6 to represent the roll. Now we're going to amend the code. The two keywords are amend and write. Amend means we're just changing the code. So we need to import the random library, create one variable, one constant, assign the result of a library call to a variable, and then display this on the screen. So it's worth 7 marks this one. Let's have a look at the actual code file called Q01. Now before I open it, what I'm going to do is actually be extra cautious, and this is my first and main bit of advice, because the biggest risk in an on-screen exam is you changing this file by mistake and not having a backup of it. And so if you opened it straight away and made a change by mistake, you could well not be able to get it back afterwards. So I would suggest at this point you're just copying this straight across into your completed folder, and importantly renaming it to be what it asks for. So Q01 finished. And make sure you do this properly. It'll be a bit irritating seeing lowercase and so on when it's been quite clear. Now we can actually edit it and modify this copy, knowing I've got a backup in the other folder if I need it. I've had in the past students come to me after mocks, thankfully, saying, oh, the code didn't work. Why did you give me code which was wrong? And actually, it turned out they just changed a line or broke it while answering a question and then couldn't get the code back afterwards. So be really careful, keep those backups, be organized as you're doing it. Now, lots of comments here, which is useful because it tells us what to do. It's a nice, easy start, or that is the intention. So, first of all, I've got to complete this line to import the random library. This is in the PLS, of course, but this is just random. Now, we've got global variables at the top. That's how Edexcel are always going to structure it. Before you've got your main code, they're going to set any global variables. And in this case, let's go back to our question. Putting stuff split screen is going to be useful. You might even have 2 monitors in the exam. So we've got to create a variable called roll and set it to be 0. It's an integer, so we're just going to leave it without any quotes. Now a constant named sides and set it to 6. Now sides is in capitals, not by coincidence. Because we don't really have constants in Python, we tend to capitalize them just to make it clear that they should not be changed later on. Okay, now we need to assign the result of this library call to a variable roll. Now it's a library call because random comes with a bunch of subroutines. We're using one of these subroutines called randint in this code, and so therefore I'm calling a subroutine from this library. To assign this call to a variable roll, it's given us an equal sign. We just stick roll on the left hand side, and finally we display the message your roll is and the variable roll. So to display messages in Python we use print. And we're going to say your roll is. It's a string, so we've got to keep those quotes. And now a few ways you could do it. You could concatenate it like this and just convert roll to be a string because it's currently an integer. Do it like that. You could also probably more simply just do a comma and leave roll in its integer form, and this would equally do what is asked. Now we can check it and make sure it's all matching. I just want to check, it'd be a bit harsh if they tricked you this way. I want to check 1 and sides is what they're looking for. So between 1 and 6, you've got to assume that's inclusive, I would say, which random is inclusive. It's a bit of an odd one out because, for example, range, the built-in range function, that second number is exclusive. We've always got to go 1 bigger if we want to include that second number. But random, for whatever reason, is inclusive, so we'd be including 1 and sides in that random range. Anyway, I'm digressing a little bit because that should be all okay. It's a nice gentle start to this program. Make sure you do test it because you may well make a mistake. Doesn't look like I have though. It's given us 6, which should be right because it's in our range. Could try it again, just double check if the randomness is working, and it looks like it is. Cool, and now it's saved in the folder. I can just close this and forget about it until I come to check it later on. Now, the next question is a longer one. It's going to take about 20 minutes and is worth 10 marks. So a programmer has started to write a program, but it does not work correctly. The program should ask the user, would you like me to sing? The user then responds Y or N, If the user types Y, then the computer displays the lines of a song. Lovely. Now we're going to amend the code again to fix a few syntax errors, change and identify to be a more meaningful name, display the question, either accept their input or not. We're not validating, that's important. You could waste time validating unnecessarily, add a comment, and add to use of white space. So this one is much more about your ability to program well, not so much the actual content, but can you debug, can you program to a nice style? And that's quite a key part. You know, I'm sure you've seen at some point, maybe even friends in the class, maybe you at some point, where code works, but it's just awful to look at. You come across it quite a lot as a teacher, people trying to be maybe a little bit too clever and their code is really hard to read. And this question is trying to train you to not do that, I suppose. So I almost broke my rule here and modified the file they gave you. So be careful, and you've almost got to go into the exam ready to force yourself to do this, because I just forgot as I was talking. Make sure you copy it across, make sure you've got your backup unedited in the student coding folder. Let's edit the question 2 file then, which is my question 2 file. And we've got fewer comments here, but still I've got a few. So let's get the line numbers up because that was mentioned. And let's get it side by side. So let's start with the errors because that's going to stop us testing anything else we do. So line 13, we've got a syntax error. Well, we could run the code and see what it says because presumably, I was going to assume that would be our first error, but it's not. We've got an error at the end. Let's look at 13 though, because I think this is a fairly obvious error. If statements have got to end, a lot of statements have got to end with a colon. Now the colon tells Python you're done with the condition. So we've got colons after subroutine definitions, colons after while loops, for loops, if, elif, else. That's important. Bit of a red herring might be these brackets. These are unnecessary. You could just get rid of these, but that's not an error. Okay, that's one error down, hopefully. Line 15, we've got another one. It's another minor one. If it's syntax, it's usually a minor punctuation or symbol or character put in by mistake. So this time we're missing a bracket. We've opened a bracket. I've got to close it. This is my function call for range. And line 17 was the one which came up when I ran the code. Which, what did it say? It said unterminated string literal detected at line 17. So essentially it's not closed. Like we've got to close a bracket after opening it. Once we open a quote, we should close the quote to signify that string has ended. That space might be another red herring. I personally wouldn't put a space there, but it doesn't make any difference. Right, those are errors done, so we can now actually modify the main functionality. So, looks like it's the comments are telling us what to do here, which is helpful. So let's just get the code up nice and big. So first of all, we want to change the identifier X to be a more meaningful name. Well, here we're getting a mark for doing it, but later questions you'll get marks too if your variable names are meaningful. So X tells us nothing about what this is, but actually, do I know what this is? What is this referring to? So looking down at the if statement, X is being used to compare to Y, and so presumably X is our user input. So let's call this, you could call it user input, you can call it response, is what I would personally go for. And because X was also down here, make sure we change it in both cases. That would be an error if we didn't change it down there as well. Okay, now I've got to display a suitable question to the user. Let's do it below this comment, make it really easy for the person marking it. And we display questions by printing again, so it would be a good question. Well, what did it say in the question? Would you like me to sing? Like so. Now we need to accept the user's input of Y or N, which part of it's done already with this if response equals Y, but to get the response, we've got to ask the user for input. So the input function is how we get stuff from the user. Now, in the code here, it separated this question from getting the input. You could quite validly do it in one swoop and just add a message in the input function, but because it separated it, it suggests to me that it wants you to keep it on separate lines. And so putting another message inside input would be unnecessary because I've already asked the question beforehand. We could test it works up until this point by running the code. I can type in Y and it does the sum. Looks like that's probably working, but if I type in N, I'm assuming this will not be working because we're missing that other part to the song. Although to be honest, saying N means you're saying no, so it's done. So actually maybe that was it. Maybe that was it. But we've got to add a comment to explain the effect of the range function's last parameter set to -1. So a parameter, I'm losing track of my stuff here, which is a risk in this exam. A parameter is a value given to a subroutine. So we've got 5. 5 is our starting point. -1, another, which is another parameter, is our endpoint. And this last -1 is the step count. So as we run it, we could see that it was counting, when I said yes, it was counting down. Let's try that again. It was counting down from 5 to 0. Starts at 5, ends at -1. But I mentioned when we were doing question 1, range function is exclusive, and so it's always going one further than you need. So we're not going to -1, we're stopping just before, which is 0. But we're counting down -1 each time. Now, if you were blanking what that was, you could check the PLS, but also just tinker with what it is, making sure you put it back to what it was before afterwards. You can see it's now going down in -2. So therefore, we can add a comment saying what this is. And the red messages are all comments which start with a hashtag. So you can say the third parameter is for the step count. And that might be sufficient, but we could be really clear and say, so -1 means it is counting down -1 each time. So that you're saying what it is generally, but giving an example of what's happening here exactly. Now, if you wanted to go over more than one line, you could do a triple quote, which allows you to type comments across multiple lines. Now, was that it? We've got to add 2 uses of white space to aid readability. Now, I might have done this without really even thinking, because just instinctively adding some more spaces. Well, white space is any white space on your any gaps in your IDE. Now, some white space is really important in Python, so the indentation is really important. We can't edit this or tweak it too much. Likewise, the gaps after print, I wouldn't personally do, as you can see, but not an issue. But it is quite cramped. It is quite cramped in this code. So I would personally add a line there, and I'd also add another line here so that it's a little bit more spread out. Otherwise, you might not be that clear whether print is inside if or not. The lack of indentation shows that, but still, you might not be as clear. It gives it a bit more space. Now, I did only say 2 uses. I think I've unintentionally added a few more gaps, but I don't think it'd penalise you for that. So that's it. Double check it all works in case you made a tiny mistake adding the white space. Looks like it is working, and so we can close it and forget about it until we go to check. Now, I suspect for a lot of people that wouldn't have taken 20 minutes, and so that's why for some people you would have a bit of a gap at the end, but then you may well need to use that time later on as the questions get a bit harder. Right, moving on to the third question. So, again, 20 minutes. This one's worth 13 marks as we get a little bit harder. So, a program is needed that must meet the following requirements. This time, we're still amending, but we're having to do more work ourselves. We need to accept only numbers from 1 to 20 inclusive, so including 1 and 20. Print invalid input if the input is outside this range, and we can assume only numbers will be entered, which makes our life a bit easier. And then we're going to print the input number followed by is even if it's even and is odd if it is odd. So we're given code already. Let's have a look at this, making sure we actually copy it across properly this time. So what we're going to have to do will depend on how much code they've given us. Not loads, although to be honest, I wasn't expecting to see that bit of code, although it's wrong. so we can preempt a question here. Right, so what are we saying? We need to amend the code to fix the runtime error caused by inputting a valid number such as 4. No other validation is required. So, fine. Fix logic errors that cause incorrect or no inputs for acceptable numbers from 1 to 20 inclusive. Fix logic error that causes the program to execute even if a number outside this range is entered, and make all the messages match these requirements. Let's take this one by one. I got a bit confused with the first one, I've got to say. So let's have a little think. Now, a runtime error is where we run the code and it starts but stops midway through. So what did it say? Did it say 4? So if I type in 4, we get a runtime error, fine. So we get a type error. It says unsupported operand type. Operand is another word for data, and type meaning data type, 4, 2 forward slashes, str and int. So all inputs are strings by default, and we're trying to use the 2 forward slashes on numbers, on integers, and so we get that runtime error. Now 2 forward slashes, again you can look in the PLS, but this is doing integer division so that it will effectively round down for positive numbers. It gives you an integer and you divide essentially. So we need to make sure this input is cast so that it's no longer a string, but it becomes an integer. So let's stick int around this input so that as soon as this input finishes, the resulting string which we get is converted to be an integer so that it will work with our maths down at the bottom. So let's try again and make sure 4 doesn't completely break it. It doesn't, although it's finished, meaning there's something a bit wrong, obviously. Okay, but that's fixed that runtime error. The rest of the ones are logic errors. A logic error is where the code runs, but just not as you expect it to or as you want it to. So we've got logic errors, plural, that cause incorrect or no outputs for acceptable numbers from 1 to 20 inclusive, which is 4, right? 4 is valid and we've got nothing, so therefore we've got a logic error. Well, I mentioned when I first opened it, this code is wrong. We're looking for it to check whether a number is even or if a number is odd, and we don't do it using integer division. We don't do it using div. We do it using mod. So mod gives you the remainder when you are doing a division, and div just gives you the integer part, which is not as useful when you're trying to find out if a number is a multiple of another number. So in this case, we're looking to divide our number by 2, and if it's got no remainder left over, it must be even. Whereas, if we see the code down here, number divided by 3 equals 0 is odd. No, don't want this at all. Now, it's either going to be even or odd, and so if I change that and get rid of that whole bit of code to become an else instead, it will simplify our life a lot more. But even still, if I just changed it so that we did num mod 2 again, if I set that to be 1, that would also be a check for whether it's odd or not. But else is more efficient because it would only get checked if the previous if was false. Now, what was currently there, num mod num mod 3, is not a check for whether it's odd, because, for example, well, to give an example, 9 is odd, and 9 mod 3 would give you 0, because 3 goes into 9 3 times with nothing left over, so that would work. But 12 mod 3 is also 0, and 12 is clearly not odd, and so that test wouldn't work. Now, hopefully this wouldn't be something you'd be thinking up in the exam, because this is used fairly often. It's a fairly standard bit of code, and so hopefully you've got that in your memory, but you could figure it out as you were going. Right, what does that fix? I think that fixes a fair amount. So the last bullet point about making all output messages meet the requirements, we can do that now actually, because it does say is even, is odd, which currently it's not doing exactly. If I type in 4 again, it's going to say 4 is even, which is not is even. So I'm just going to change this so that it just says is even. Doesn't say we've got to actually show the number. In fact, that's not true. It says print the input number followed by is even. So I deleted num too early. Okay, that's the last bullet point, but I missed the second last bullet point, which says fix the logic error that causes the program to execute even if a number outside the permitted range is entered. So currently, nothing's stopping us entering, say, 25, when it shouldn't be allowed because our permitted range is 1 to 20 inclusive. So what should we be doing? Well, here, our validation only needs to be an if statement. Normally, or a lot of the time, validation will be a while loop where we keep asking and asking and asking until we enter a number within our range. But here it doesn't say keep asking. It just says print invalid input. So I reckon we should just end the program if the input is invalid. Nothing else happens, we don't get another chance. So therefore, simply all I need to do is add an if statement checking the range of num. So we're checking, well, is num greater than or equal to 1 and less than or equal to 20. So this is quite a nice way in Python you can do, which I only just learned fairly recently, to specify the range in quite a mathematical way you're probably used to. So if it is within the range, that's perfectly fine. We can run the rest of the code. Now, to make sure this code runs only if this if statement is true, I need to make sure it's inside the if statement, and I do that by tabbing it across so that it's all indented within the wider if statement. So if I just delete a few lines here to make it a little bit clearer. Well, now, if it's not in that range, it's an invalid input, and so I can just print invalid input, and I reckon that should be it. Nothing else should happen, the program ends and they don't get a second chance. If it says something like keep asking until it's valid, or ask again, or don't move on until it's valid, that implies you should be using a while loop, but without it, if statements will be sufficient. Let's do a final test to make sure this is working, and you'd possibly want to test it a little bit more than I'm about to. Test it with a few different inputs. 2 is even, 2 is valid, that's perfect. If I did -5, we get invalid input, perfect. If I did 17, perfect. Try and do some boundary cases. So what about 20? Did I do that right? 20 is even, perfect. Whereas say 21 is outside my range and so is invalid. Looks like it's working. Do a few tests of things which may or may not break it and see if it does. Moving on to question 4. So let's get that code up and backed up properly in my completed coding folder. I would suggest in the exam only keeping one open at a time. I've heard from my own students getting in a right mess because they've got 17 windows open. Try and keep it as simple as possible. By saying that, I've got a million open myself. Right, this code, I was going to say it looks a lot longer. It's actually quite short, just lots of comments at the top. So, how many marks is this first of all? It's 15 marks now, we're getting a bit bigger. A program takes a year group as input and outputs the stage of education the year group belongs to. The program loops continually until the user inputs 0 to stop the program. By the way, these questions do build up in difficulty, maybe not always perfectly, but that's the general idea. And so loops might not really appear until you get to a few questions later on. Although I think question 2 had a for loop, just one you didn't have to actually do much to. Right, so it's giving us some values here and what the result should be. So 0, we should exit. Then we've got primary years, secondary years, and college years, like that. Now the lines of code in the program are mixed up, and so we've got to amend it to make the program work and produce the correct output. We've got to rearrange the lines. It's a bit of copying and pasting. It's why having a backup is ultra important here, in case you make it even messier. We should use comments, white space, indentation, and layout to make it easier to read and understand. We shouldn't change any functionality or add anything to this. Great. Let's open up and have a look at this. So we're told not to move the top two, which is great. Now it's giving us another copy of the data and the expected output, which is great as well. Makes it easier for you. So this is a bit of a mess here. I would be tempted to, what would I do here? I think I would comment out the stuff at the bottom. So stick a triple quote before it and just take it bit by bit above. Right, so we've got the year and the string year, fine. We've got two inputs which are the same line, apart from that one's got a, no, they've both got brackets. Okay, let's take one of these because we probably need to first of all ask the user for what they want. We've got it twice, so maybe I should cut it so we know we've used it already, or delete it so we know we've used it already. And the fact that I've got a year and a string year suggests I've got to cast it to be an integer. So let's do that. We've got two casting lines here. Let's cut that and put it in. Afterwards, it's got to come afterwards because otherwise you can't convert something you haven't got already. Now we can probably start checking to see if it is there or not. Now it does say the program loops until they enter 0. And I was going to say I couldn't see a loop, but you can see a while loop at the bottom. And so let's take that because most of the code is going to be in a loop, or at least a decent chunk of it is. So we keep looping until it's in a valid, until they enter 0, I should say. So inside this while loop, we're going to be doing the checks and then asking again before it loops again. So actually let's ask again before we move on because that's something you could forget if you're not careful. It's really important in while loops that they end. A while loop is indefinite and so it will go on forever unless this condition is broken. And so it's important we give the user a chance to enter 0 eventually, which means you've got to repeat these lines of code twice. So we've asked outside the loop, but you've got to give them a chance to enter it again, otherwise it will become infinite. But that's not going to be the first thing we do, because otherwise it's going to ask them twice for the exact same thing. We'll put that at the end. And what should go at the top are the if statements. So if is going to come first, then we have elif, then we have else. That's going to be easy in our structure. Just make sure the indentation is correct. Now these elifs may not be in order. We've got to have a look to see what fits in a minute. But then else will come at the end. Now I added indentation myself with just tab. Keep it really consistent so that it's always the same level. This is inside the while loop and so therefore must be indented one level across. But the things inside the ifs and elifs have got to be indented another level across so that they're within those constructs. Now, if year is less than 1, we are going to say, well, I assume year too small because we're not going to get any smaller in this particular problem. But we can always move that if we need to later. And what about year too big? Well, there's not a year above year 13 in the English school system, or UK school system, I should say. So therefore that's year too big. Again, whether it's in that position we'll look at in a second. College is good. Well, let's see about college in a second because there's nothing directly college in the ifs and elifs, but we've got secondary. So secondary is going to be less than year 12. Let's put that there. Now primary is 2 because year 5 is less than year 12, but we've also got an elif which must be for primary. So therefore college is going to be under the else. And that's all of our code, so I can delete my long comment at the bottom. The issue is the order is wrong here. So if I try it, it's not gonna be good. It might be worth trying it at this point just to double check you haven't made any syntax errors by mistake. So if I type in say year 8, let's see. It says secondary to be fair to it, Let's try 16, just too big. Did I say too big? But if I tried something like year 4 works too. What about year 12? College, year 13? College. Oh, it's looking decent. I was pretty sure this wasn't going to be the correct order, but let's have a look. The reason why I wasn't sure was I was expecting this to be a little bit off, but actually these are ELIFs. I was thinking it might be ifs. If they were ifs, everyone would get checked, but if they're ELIFs, it goes one by one. Now, if, for example, year 12 was put above the year 7 one, because both are less than, and because it's ELIF, it won't check year 7. It won't check, sorry, this ELIF here. If you typed in year 4, which I'll do in a second, it's going to print secondary, not primary. Primary will never get checked because ELIFs skip once one of them is true. It won't check the rest of the selection. So let's try that just to prove my point. I think I said year 4. So it says secondary and won't say primary. So the order before I just broke it was actually correct, I think. I will double check in a second. So less than year 7 is primary, greater than year 13 is too big, less than 12 is secondary, otherwise it's college. So it looks fine, but the main concern would be, like I say, these two less than ones. That order is really important. But for some reason they gave it to us in the correct order. I was expecting that to be a little bit harder, but that seems to be working, seems to be fine. Tempting to move on at this point, but I do remember seeing a line of the questions saying we've got to add comments, white space, indentation, and layout to make it easier to read and understand. So layout is really, are you putting stuff in the correct place? The layout is sort of done for you to an extent. It's set for global variables to be at the top, then the main program is down here. This is fine as layout. If you put all of this up in the global variables bit, that might lose you a mark. But we can add some comments. I think white space is pretty good. I've added gaps between my selection constructs. I think it makes it a little bit easier to read. Added a gap after else, again, easier to read. And the indentation I didn't really have a choice about, but I added it to all of the bits inside the while loop. But comments I can do. So, what is worth explaining here? Because you've got to be careful. There's not much point asking adding a comment to every line of code because a lot are self-explanatory. But I think the first one which I think stands out is the last 2 lines of code, because it looks a bit odd repeating these 2 lines after they've been done already. But we're doing this because we need to ask the user to enter another value. This prevents an infinite loop. So if I removed or commented out these 2 lines and ran the code, we are never going to end because we never have a chance to enter another number. So we've got to give the user a chance to enter another number. I typed Control-C to end it there, by the way, if you ever get stuck in an infinite loop. So you've got to have those last 2 lines. What else would be useful to comment on? So we could start by saying ask the user for a year group and convert to an integer so it can be compared. Later on we can't actually compare it properly to 0 here and minus less than 1 here unless I have it as an integer. So if I don't do it as an integer, nothing happens because it can't really compare it properly. We can add a comment for a while loop, so I could say this code will keep checking and then asking until 0 is typed in. And we could do another one for our selection block as well. Check each condition 1 by 1 using the user's input, which is year. So you could add more, you could add less, you could be more detailed, be maybe a little bit more vague. That's the sort of thing you're looking to do, just to show you've followed that point. But again, don't do every line of code, and try and make it so that it would actually be useful if you were looking at this for the first time. Before you close it, do a last check to make sure you haven't put in any syntax errors as you were typing that. It looks okay to me. Great, now moving on to question 5, which is meant to take about 25 minutes. I haven't timed myself, but I think I'm a bit ahead of things. You may take longer, of course, it's absolutely fine. So students are collecting data about the amount of water needed to fill different size paper cones. Their measurements are compared to a calculated volume. And it gives us a volume for a cone, which is volume equals 1/3 pi r squared times by h. So r, our radius, h is our height. And we've got a program and subprogram started to carry out the calculation. So let's have a look at this after I've copied it into my folder. So now on question 5. Right, so got to import another library to use pi. We've got some global variables and we've got a subprogram. It says subprograms. So we've got a definition of a subprogram started here, also called a subroutine. Going back to our questions in a second. So we need to amend it to meet the following requirements. The subprogram must work for any values of radius and height passed as parameters. You can assume values passed to the subprogram will always be numbers. No validation is required. Validation is what we've done before, where we were checking the range being acceptable. It's where you are making sure the input is what you expect it to be or is in a format you need. Now the subprogram must calculate the volume based on the input parameters using the formula above, and it must print the volume formatted to show 3 decimal places, e.g. 16.135. Okay, excellent. So just filling in gaps here essentially, and it's given us some details at the bottom down here. Now, first of all, import a library to use pi. Well, you might know this just from memory, and hopefully you would, but let's say you didn't and you were thinking, oh my goodness, what on earth am I going to use here? What you should be doing is looking in the PLS, either the one in front of you or the one on the computer, to see what is here. Okay, so I would be, you should ideally know this better than I would at this point, but we've got library modules, we've got 4 listed here: random, math, time, and turtle. Which one's pi likely to be in? Well, you can double check if you need to by going to page 11. And we've got in math, pi. So math.pi is pi. So therefore, I've got to import math to be able to use it. And you can be annoyed that it's not maths, as I am every time I use it. Okay, that's our first bit done. Perfect. Now I'm not going to touch these global variables. We just need to finish the definition of calc volume. So def calc volume is my name, and then brackets are where we put our parameters. So parameters are variables used as input to our subprograms. So what parameters do I need? And I can't just put any name I want here, because it's got to match with the code already here. We shouldn't change too much. So the code currently here has p radius, p height, and the volume. Now, it's possible these were global variables, but they're not listed anywhere above or anywhere below. So therefore, these are variables just used in the subprogram. And because they're not assigned anywhere else in the subprogram, they're not local, they must be parameters. So we're kind of filling in the gaps here a little bit like a detective. And we can see we've got p radius, p height, and the volume. So although the volume I put in without really thinking, the volume is not going to be a parameter, because the whole point is we're calculating the volume to give out at the end. So I don't need that as a parameter. I think I only need p radius and p height. P is, I'm sure, short for parameter here. Yes, all I need is the only 2 missing variables on the right hand side are the radius and height. 1/3 and pi are both constants. So the next step is to use those constants when calculating the volume of our cone. So we should do this as a variable. The volume has been used but hasn't been assigned, and so this will in fact be our local variable assigned just in calc volume. So what was that formula again? It was 1/3 times pi. Well, how do I get pi? Via math and via the PLS we saw that it's math.pi. So all I do is just go math.pi. And now we're timesing this by, what was it, the radius squared? Yeah, radius squared. Now radius is p radius. And to square numbers in Python, we don't do one asterisk, we do two asterisks, I think, or asteri, I'm not quite sure of the plural, like this. Now I'm putting brackets around a third and around the power just to make sure any dodgy orders of operation don't ruin our calculation here. And finally we're multiplying this by the height. I'll just double check, but I'm fairly sure that's right. And that's our calculation, it should be at least. Now, print the volume is the volume, and now we should return the volume to the caller. Well, a subprogram which returns a value is called a function, and we do that in Python just by typing return in lowercase. It's a keyword, so in idle it will go orange, and we just write what we are returning. What this means is this value will replace the calling statement, which we're having down here, and as it says, catch the return value in the correct variable. So it's going to give us the value which we've got to catch in this in a variable. So let's do that. What would be a sensible name for this variable? Or does it give us one already? I think it gives us one already because cone volume is set to be 0. And so let's use cone volume as our variable. It also appears down here. So it can't be my own one. I've got to kind of fill in the gaps and match what they've said. And now how do I call a subprogram? Well, all I do is write down the subprogram's name, which here is count volume, then add brackets. And I need to, for each of my parameters, I need to put in the values I'm going to use. And the values I'm going to use are cone height and cone radius. Now, in my definition, I have put the radius before the height, and so therefore in my brackets it's got to match up. So despite cone height coming first in the listing at the top, I need to in fact put in base radius first. Then I can put in cone height second. It's got to match up because as soon as I call it, it jumps up to the definition, replaces p radius with base radius and p height with cone height. Then when the subroutine finishes, this bit goes and it's replaced by the return value, whatever was returned. Perfect. Probably a good time to test it before I try the last line of code. This is print cone volume with no formatting. I'll just comment this last bit out. So volume is this long number, and we need to now make sure it goes to, I think it was 3 decimal places. If that looks about right to me. Did it give an example in the question? It may have done. Yeah, so it tells us it should be 16.135. So our code is working, just minus that last bit about formatting it to 3 decimal places. Now it's kind of forcing us to use dot format, which I have to say I'm not a huge fan of. I never really use this myself when I'm coding because I'm a little bit stubborn. But ultimately, it gives us code. We've got to fill it in with the way they do it. So dot format is going to be on page 10, it turns out. So my aversion to dot format is partly because there are these codes you've got to learn in this case, right? So thankfully it does give us a nice summary and does give us a fairly useful example for how to use it, although in an exam situation trying to figure out what this is doing would be a little bit stressful. So hopefully we can go through that now. So this example gives 3 uses of dot format. So in this case we've got 3 separate placeholders for 3 separate values. So Fred will go in our first one, 358 will go in our second one, and pi will go in our third one. So these are placeholders. When you run the codes, they get dumped in order, the stuff which comes in the brackets. So the kind of general structure we can fill in just now is, well, it's given us the curly braces already. We also have a colon, then we put a little bit of the code. Now I'm only putting in code volume, so I've not got multiple of these placeholders in my string. And you can see this example's got the string stored in a variable before it's used, whereas in this code already, it's doing it in one swoop. Right, so looking at thread first of all. Now it's not that clear because it could just be centered this way. You can see the image as I highlight it. Actually, what this code is saying is, right, we're going to align thread to the right, and my box thread is going to be in is going to be 10 characters wide. So if we counted the number of characters here, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 in this kind of imaginary box here, and because we've got that greater than sign, in this context, that means you're aligning it to the right. That's why thread's there and not in the middle or to the left. Now for 358, because it's not a string, we've got to tell it what type of number it is. And 358 is an integer, which is why there is a D down there. So integers, you put a D, floats, you put an F. Now this time we are aligning it in the center. And again, if we imagined kind of a box here, we would have a character either side. So we've got space for 5 in total. Now again, confusingly in this particular example, we've got another gap after thread. This gap is because of the space between our placeholders. So again, it makes it look a little bit weird. Now, speaking of looking weird, the pi at the end here, we've got space for 7 characters here. So 1, 2, 3, 4, 5, 6, and 7. We're not using all 7 in this particular example, but we could have another digit at the front here. Now the .4f bit is saying we're going to cap this at 4 decimal places. So you can see we're rounding the last digit up. So it's 3.1416, not 3.14159. So it's doing that rounding for us, in this case, to 4 decimal places. The 7 is about the width of this kind of imaginary box, which if you were trying to format like a nice table, dot format is really useful, but a lot of it is overkill for this particular problem. So all we need is the colon, as always, and .4f, except that we're not doing .4f because we're not doing 4 decimal places, we're doing 3 decimal places. So it should be .3f. Don't forget the colon, don't forget the dot. It wouldn't work properly if you did. Right, awkward. You can see why I'm maybe not necessarily a huge fan of this, but it is useful if you're trying to format things properly. It's just we don't do that so often. Right, I run it and I get the correct output. This output here is my line I added myself, so I'll undo that. The unrounded version was already there inside my subprogram. So I think we're done now at this point. It didn't say to format it in a particular way, apart from putting it to 3 decimal places. So that should be fine. Doesn't mention adding comments in this case, and so I would not volunteer to add comments unless you are specifically asked to. Let's now start question 6, which is the final question in this paper. It suggests 25 minutes. I think, I don't want to say worst case, but you wouldn't want to get to a point where you've got 10 minutes left and you've got to do the hardest question on the paper and try and get just as many marks as you can get. So I'd really suggest, unless you find programming so hard and this might be beyond your reach, I'd really suggest you maybe even move on from earlier questions if you're finding yourself at question 6 with not loads of time left, because this is a question which in theory takes the most thinking time and can't be rushed the most, and also the one which you don't want to be stressed or tired when you're going to answer it. So, right, this is across 2 pages a little bit awkwardly, but let's read through it all. I would suggest you read through every single bit before you get started. So a program is needed to authenticate systems logins consisting of a login name and a 4-digit passcode. These items for current users are stored in a 2D list with 19 records, The list contains user number, last name, first name, login name, and passcode. So before I move on, so if you're authenticating, you are checking somebody is who they say they are. So clearly this is storing 19 users, their details for a login system. We're told the list is sorted by login name. That might influence what maybe we need to do a search and might influence what searching algorithm we use. All users have passcodes that are integers between 1000 and 9999. Doesn't say if that's inclusive or not. It does say that here. Right, we need to write a program to meet these requirements. Write means we're getting the least amount of structure. We've got to do most of it ourselves. And it separated this page of requirements into inputs, processing, and outputs, which might help your flow here a little bit. It might not. So read through all of it just in case. We're going to, for our inputs, first of all, prompt for and accept a login name with no validation required. So just a straight input here. Prompt for and accept a 4-digit passcode, and we can assume only numbers will be entered here. Are we gonna, so fine, we're not checking if it is a string or not at this stage, but should we be checking it's 4 digits only? Not sure. Although, yeah, we are. So it does say the next point. I should really read all of it like I suggested. So we need to ensure the passcode is between 1000 and 9999 inclusive. So we are checking it's 4 digits via this range check. Right, if it was 5 digits and it was a number, which we can assume, it's outside of this range. Okay, so this isn't too hard. Now, I would be, if I was doing this myself, I'd be highlighting as I was going. You are allowed to write on the paper. It will just get binned after you are done. Now, the word ensure to me, not always, but a lot of the time, suggests that you are going to keep asking until it is within this range. If it just said, check the passcode is in this range, that might just be a straightforward if statement. But the word ensure, to me at least, from reading lots of exam papers, usually implies a while loop is needed. So that you keep asking until it is within this range. Now it's a little bit vague, so that might not be for sure in this particular question, but that's my read of it. Now the process, we've got to work with any number of users in the list. So it needs to be adaptable. So 19 was listed. I'm doing this with my mouse, so forgive me. 19 was listed, but it should work with any number, not just 19. We need to, so I mentioned maybe the fact that it's sorted affects our searching algorithm, suggesting that it might be binary search, but actually it tells us to use linear search, which is easier, which is great. I think doing binary search in an exam would be a little bit harsh unless they gave you a bit of a code already, but maybe be prepared for that. So we've got to use a linear search to find the record with the correct combination of login name and passcode. Stop searching when the location of where the record should have been found is passed. So we finish as soon as we find it. So if we're looking for Jan 118 and find Joy 116, then the record is not on the list, so the search can stop. Oh, okay, I see. So that is interesting. So it's not just a straightforward linear search. We are using the fact that it's sorted as a factor. So because Joy 116 would be because Joy 116 would be after in the list, I think. That I'm a bit confused with that point. So this is the sort of spanner in the works which could really throw you if you're stressed and panicking at the end of your exam paper. So giving yourself enough time to think these sort of things through would be helpful. Now I've copied the code across already. I figured you saw me do that enough times already. So I've got it in my completed folder here. This is the code you're given for question 6 in this particular paper. We get the user list predefined. We've got, I assume, 19 users in here with their user number, last name, first name, login name, and passcode. The main program is empty, which is because this is a write question, not an amend question. So, going back to that dilemma, what exactly is meant by this? So Jan 118. Have we got Jan 118 in this code? We do not, but we do have Joy 116. So let's read through what it said again, just to make sure I'm happy with what it's trying to say. So stop searching when the location of where the record should have been found is passed. So for example, if looking for jam 118 and you find joy 116, then the record is not in the list. So if this username is bigger than the one we're looking for, we must have missed it, and so we've got to stop. Now, it doesn't look necessarily sorted because it's alphabetical, but let's look at the shell and just check this. So joy 116, I believe, is actually bigger than jam 118 because, well, J is the same in the alphabet, but O comes after A, so it works sequentially. If we try another one, let's try J-O-A, and let's see, well, this should be smaller than J-O-B because J-O are the same, but then A is smaller than B. Now, behind the scenes, this is working using ASCII codes, but we can use that to our advantage just by doing a straight comparison of the strings. Okay, phew. Now, that's a bit confusing. That's the sort of thing you might, if you're running out of time, you might not think too much about and just try and pick up marks in other areas. But that's obviously the harder aspect of this problem. It says we do not need to loop continuously. I'm not exactly sure what this means. It could slightly go against what I was saying about ensure. Maybe we don't need to do that while loop. I think I still will anyway because it's a little bit ambiguous. Maybe it means, you know, if it's missing, you don't give them a chance to have another go. Perhaps that's what that means, but it's a little bit unclear. And for the outputs, we're just going to display a welcome message, including their first and last names, if the login name and passcode are found. So it's not just a welcome message at the very top, it's only if you find their details. Alternatively, we're going to display an invalid input message if the login name and passcode are not found. And that's the only two prints in our code. And we've got to, at the bottom, use comments and whitespace and layout to make it easier to read and understand. Okay, lots to be getting on with. So let's start with those, let's not minimize that, let's start with the inputs. So prompt for and accept a login name and then this 4-digit passcode. Well, we're going to do this in my main program because the global variables part is just for our global variable definitions and initializations. So what would be a good name for our login name? Or just login name will do. And when it says prompt for, prompting is where you give a question or bit of text to the user before they type in input. Let's just use input and say something along the lines of enter your login name. So this, as a string, is our prompt. And it'll accept login name when they type in their login name. Now the passcode is maybe a tiny bit more, it needs to be a little bit more developed because we are going to validate the passcode to ensure it's a number inside that acceptable range. And so because it's a number, we can't just leave it as a string. Login name should be a string, but passcode, if I'm going to check it in that numerical range, has to be a number therefore. So let's stick that as a number by casting it to be an integer. Now these are global variables. I've initialized them down here, but if you've noticed, Edexcel like to initialize them at the top anyway. So if we want to follow that convention, which I would suggest if you're being safe you would, we can initialize it at the very top. Now if I'm being honest, there is little point of doing this, but it's what they've done throughout all of the other questions, and so if you want to be safe, you might as well do it just to follow that convention. Right, this validation, let's check whether it's in this range. Now I think I am going to go for a while loop. If you went with an if statement, you might be fine, but ensure most of the time I've seen that across many exams, it suggests a while loop. So let's do that and just keep asking until it's inside this allowable range. So it needs to use a while loop, not a for loop, because we don't know how many times it's going to loop, and a while loop is indefinite. Well, what is invalid here? What we're going to keep looping for? We're going to keep looping while the passcode is less than 1,000, or passcode is greater than 9,999. It's less than and greater than, not less than and equal to, and greater than and equal to, because it said that range is inclusive. Now that range is our acceptable range. What I'm checking for is the unacceptable range, what goes outside this allowable range. And it should be or, because it needs to be either side is true. It can't be and, because no number is both less than 1,000 and greater than 9,999. It's got to be or in this particular case. And a common mistake is not fully writing out your condition, doing something like this, which looks fine from a maths perspective, but does not work in Python. So if it is outside this range, all we're going to do is just ask for the passcode again. Maybe let's print a message saying invalid input, try and enter the passcode again. Something along those lines. Maybe we could even be more specific, say invalid input, not 4 digits, try and enter again. Something along those lines. Because 5 digits would be greater than our top limit, and 3 digits is less than our bottom limit. Right, that's our validation done. So once we're happy the passcode is correct, we can move on. But what I'd be tempted to do is actually test whether what you've just done is correct, because I've definitely seen my own students, especially at A level, write a long solution in an exam, run it, doesn't work, panic, and then they're debugging for 5 minutes. It's better to do it in small chunks, test it, move on, test it in that cycle, because it makes it more manageable to debug. So login name doesn't matter right now. The passcode, if I enter say 4, that should be invalid. If I enter say 444, also invalid. If I enter say 10,000, that should be invalid. But if I enter say 5,000, that should be perfectly fine. So the loop ends and I get test. Great. So let's do the main bit, which is linear search. Now we've got this 2D list up here with each of our records. So we've got 19 in total, I imagine, without counting it. So what we're going to be looking for is to iterate through this 2D list, checking to see whether what the user's typed in matches any of the records in this 2D list. So we're only interested in the login name field inside each record and the passcode field, which are the last 2. So I don't really care, at least initially, about any of the other fields in this 2D list. Now the general way we iterate through a 2D list is with code like this. For I in range, the length of this 2D list, which is called user list, and then do another for loop inside it. So this double for loop is how you'd go through every single item in this list. So if you actually check every single item, you'd use a nested for loop like this. The difference between the inner for loop is we've got to use the length of the particular record being checked, so that it's going through a record, then going through each individual item inside that record. So it looks a bit like this, and then you can index user lists with I and J. Now if you're wondering why I'm doing this, I'm only doing this just for a quick, what am I doing here? For a quick example, because we don't actually need a list like this, but this is, what have I done here? But this is useful in lots of cases. I've just lost a bracket, very common error. It wasn't a colon, it was a weird error message, but it was a bracket. So let's just do this again quickly. And then we get every item in that 2D list. So if you're looking to go through every single item, you would use this structure, and you've just got to memorize that essentially. Now we don't need every item. All we care about is the last 2 items within each record. So really, having an inner for loop is unnecessary in this particular problem, because all I need is that outer index, at least initially. So when it mentioned in the paper about it needing to work with any number of users in the list, this code will work with any number of users because I'm using the length of the list. Now the length of the list is currently 19, but if you added lots more users, the length would be updated, and so it would work no matter how many users we had in the list. That's what it means. It doesn't want you to be hard coding it to be 19. Okay, and I'm just going to use a for loop to go through this because we know how many items there are. It's however big the length is. And so a for loop works best. Could use a while loop, but I think personally my instinct is to go for a for loop every time we're iterating through a list. So we're going to be checking to see whether our last two items match up with what the user has typed in. So an if statement is a way to check this. So if user list with an index of I, maybe I actually call this index to make it even more readable. Now I is very commonly used in for loops, but writing out can't harm your readability marks. So if user list with an index of whatever it is, then I need to put another index number to specify which item within this record. So just to be clear, because maybe I didn't explain this, the way we go about indexing 2D lists is, first of all, we've got to have two index numbers. It's a 2D list because it is a list of lists. So we've got 19 lists within a wider list. That's why it's 2D. And so the first index number gives us the individual record. So one of those 19 lists we get using the first index number. But to go inside that one list, I've got to use a second index number following the first one. So as you hopefully know, we always start indexing from 0. So this is our 0th item, first, second, third, or maybe not third, it's maybe not quite the right word, but it's our index of 3, which is our login name. So if I want to check my login name first of all, I can hard code it to be an index of 3. This is why that inner for loop was not necessary, because we know it's going to be always indices 3 and 4. Right, so we're checking, does this login name equal our user's login name? And we're also checking to see, does the following item match our passcode? Because we can't have a situation where their username matches, but we're allowed in even if their passcode is wrong. Both sides have got to be true, otherwise it's a very weak system. So checking, does it match up? Does this item, whichever one it is, match up to our users? If it does, we can say welcome, and I know we've got to write a bit more later on about welcome, but we'll leave that for now. Now, crucially, we want to be efficient, we want to stop searching. We want to stop searching when it's found. Well, it doesn't necessarily say that, but a linear search is not very efficient if we don't stop searching once it's found. So if I just printed welcome here, and we found the item, but the item was fairly early on, it would keep looping and keep looping and keep looping until it's done, which is not very efficient. If you've found the user, there's no point continuing to loop. Now in a for loop, and a while loop for that matter, a get out of jail free card is break. So what break does is end the loop early. So we've got a for loop, we've got this sort of start and end point. It's going to start at 0, end at the length of our list, but break will end it early. So it's a way to end a loop early, quickly. Whereas an alternative might be to use a while loop, and you can use break too, but some people are not a big fan of break, and so we'll use something like is found as an example. They might be like while is found equals false, blah blah blah. Then once it is found, they might set, instead of break, they might set is found to be true, and that will have the same effect of ending the loop early. But in Python, you don't even need to do this. You can use break as an alternative to that. Most other languages don't use break. They have to do something like I just showed you, where you're using a Boolean value to toggle the loop being running or not. But Python actually, as kind of brutal as it is, has a simpler way to approach this. Cool, well let's test if this is working or not, because otherwise, you know, this code might not work. I made a few mistakes already. Let's just print test again at the end, just to see if we ever reach that point. So who am I going to be looking for? Let's look for Kai 1110 and 7005. So validation works, we know this already. So let's check that again. So login name Kate. In fact, let's not do that one because it's at the first one. Let's do a more useful one. Let's do Joy116 and her username should be 8869. Welcome test, that looks good to me. Welcome to test, it's found that correct username. Whereas if I try this with a wrong one, we should just get test because it's not found it. It's completed that for loop without finding that wrong username. Now, how can we test whether it's done or not? We could print every time we check one. So we could print checking every time we're doing that and just see if it is breaking early, which it should be, but just in case. So Joy116 8869. So checking. We find it, we're welcome, and we're done. So we know break is working by just adding that print line. And look, if you've got the luxury of time, this is how I'd approach it. I would try little things out, test your code using different techniques. Of course, if you've got 5 minutes left, you're just writing as much as you can. So I appreciate it just depends on your status at this point. Okay, now that's not our entire program. That's basically our linear search done, quite honestly. But that whole issue about stopping early when you've kind of gone past where the record should be is something we need to also consider. And that's really a way to boost this efficiency. A lot of the time, or most of the time, linear search won't be sorted. And so this is just a rare case where linear search is sorted, or the list is sorted, and so we can apply this other technique. So a way of checking this is by adding another if statement or even an elif statement. It doesn't actually matter in this case, because if was true, we would have broken. But what is the check here? Well, the check is let me think, is our login bigger than the one we're currently checking? So we saw that Joy was bigger than Jam, at least according to the weird string comparisons, alphabetically speaking. And so if we come across one which is bigger than our item, it can't have been there because it's sorted, and so we can end early. That I think is my understanding, but we can obviously test this. So if our login name is, what did I just say, is bigger than our current login name we're testing for, which as we saw had the index of 3, 0, 1, 2, 3, and therefore we haven't found it, and so I think it said invalid input, but we'll tidy this up a bit later. And we also want to break, so we're ending it early is the key idea here. Now, let's test this before I say now and do something else. So how can we test if this is working? Let's test with Joy and Jam, because that was what was in the question. So we know Joy's working, we know that username could be found. Let's have a look at what was put down as Jam. So Jam118, let's have a look. So I type in Jam118. Passcode isn't relevant here because it's not in our list. We get invalid input, phew. That's a good sign, right? Because it means we're, well, I assume it means we're ending early because it wasn't found. Again, we can add another line if we want to be, if we're a little bit paranoid and are not trusting whether break is working or not. But this should be proof that it is ending early if it can't be in the list. Yeah, so check, it's only checking once, is that right? No, that can't be right. So that's not good. Why is that happening? Well, I'm actually not sure. So what I'd be doing at this point is seeing what is going on. What am I checking? What has caused it to not quite work? Now it must be this second line, but I can't quite see why that would be. Let's have a look. Right, so Jam118 we know is not in the list. So it's checking the first one, and then it finds this to be invalid. So why is that? Because jam 118 okay, so I've got this wrong way around, surely. Right, so because jam 118 is bigger than this username, because J comes after C in the alphabet, it's breaking straight away. Good job I checked, because I would have genuinely missed that one. So it should be less than. Am I content with why that is? Yeah, so once we go past one which is smaller, we know our item wasn't there, because it just doesn't make sense anymore. We know it's in order, we're working our way up in order, therefore it's got to be, our item's got to be smaller than the one we are checking. Okay, I think that makes sense, but we'll just double check this, of course. So jam 118, doesn't matter the passcode. Phew, that looks a lot better to me. Right, that was confusing, I was very confused by that, but that's how it goes, right? That's one of the harder aspects of that question. You just need confidence that you can fix it with a little bit of problem solving, a little bit of debugging. Great, so forgive me because I must have said that the wrong way around lots of times, but it just takes a bit of trying sometimes to see if it is working or not. Okay, so you can see we're getting to joy, realizing that actually our login jam can't be there because it should have come before joy, and so therefore we're breaking and ending early. Cool, let's leave or get rid of my lines which were used just for my debugging. The thing which is missing now is what happens if our item is not on the list at all. It'd be good to have a backup just in case our item is not there and we haven't got any X, Y or Z's in the list already, and so therefore if I typed in X, Y or Z it would not break because of this reason. So a way to check, essentially if a for loop completes and neither of these two things have been found, if it completes without breaking, we know the item also cannot, or we know the login also cannot be in this list of users. So when you've used break, you can actually stick an else clause on a for loop, because what this code will run only if a for loop has ended naturally. So if this for loop has gone through every item and ended, it's going to print invalid at this point because our item can't be there. When I say naturally, that's because break will not cause else to run. So else will only run when it's attached to a for loop if there hasn't been a break. So this will get run right at the end if it has not broken, which means it's checked every item. Now, if you didn't know that, not everyone does know that, this property of using else. You could be doing something like, well, elif index equals len user list -1, and then you could do that final check. And if it is that, then that's also invalid because it means you've finished checking all of the list and I wasn't found. So that's kind of an alternative, but else print invalid is a little bit nicer to look at. Okay, again, let's check this. So let's try this with X, Y, or Z. Let's do Z. So I did that wrong somehow. Let's do Z, and then 1, 2, 3, 4. So we should get just invalid, not just invalid input. We know that's right because it means it's completed every check and it's done and couldn't find Z in the list. Okay, so let's now just tidy this up and make sure our formatting is right. Then we've got to add some comments and that should be us done. So let's look down at the output bit. So we've got to display a welcome message, including their first and last names if it was found. So let's make this welcome message a bit nicer. So to get the first name, well, the first name, if we look at the comment up here, is our 0, 1, 2, our second index in each record. So I can print welcome, comma, user list. Index is currently our particular record we're on. And then I can use 2 to get the first name. To get the last name, I'm going to do the exact same, but the last name comes before the first name in this particular record. and so the last name is 0, 1. Like so. Let's see if that's looking a bit nicer. Right, so I've forgotten what it was. Was it Jam 116? What was that? Oh no, Joy 116. Let's try that again. Joy 116, and her password was 8869. And it says, welcome Betsy Johnson. Great. That's much better. That's meeting that requirement. What about invalid input message? Doesn't actually say what to mention there. We're not mentioning their name or anything because it wasn't found. So we can just say invalid input. To make it nice and readable, we can actually say what is invalid about it. We could say not just invalid, but we could say invalid input login and or password not found in list. And we can do the exact same thing down here. Now I think, unless I've missed something obvious, that is all of our requirements needed. Now when you go to check, you'd hopefully go through and tick off each of these as you're going. But that's our core code. So let's add some comments to make sure this is nice and clear. Because the way I approached it is not the only way to approach it. You could use a while loop instead. You could use some toggles. You could have done a few different things. You could have not used else like I've used it here. A few different approaches. So we could add a comment at the top saying initializing the inputs from the user, because we're going to populate those with inputs down at the bottom. Like I said before, these are not necessary, you don't need to do these two, it's just how Edexcel seem to be wanting to do it. Be here asking the user to enter their login and passcode. And now we are validating the input to ensure it is validating the passcode specifically. It is a 4-digit number. And now we're going to check each record in the 2D list. That's what the for loop's doing, it's going through each record. And the first check is to check if the current record has a matching login and passcode with the user. Then maybe it's not always clear what break is, so we could say down here it could be like, right, we're gonna, if it matches, we're gonna print welcome with their name. Then end the loop early since their record has been found, right? We don't have to break at this point, we could just keep checking, but it's a waste of time and so it wouldn't be very efficient programming. There's no point continuing to check the list if you've found them already. Now this one down here is maybe the one which I got confused on, and so is maybe needs a bit more description. So if the login name is didn't match the current login being checked, and it is smaller, because essentially with the first bit we've checked to see if they match, or they don't match if it's got to this point, and if our login name is smaller, then the user's login name can't be in the list. And so we end early, you could say that. So the search ends early. And this else bit at the end here is just to see if the loop has finished checking every item and a match wasn't found, let the user know it. Let the user know it. Does that make sense? If the loop has finished checking every item and a match wasn't found, let the user know this is a little bit better. That should be enough. That's a comment for almost every aspect of the code, maybe a little bit overkill, but if you've got time to do this at the end of the exam, it's worth it. Another check to make at this point is your white space. is this bit cramped? You can argue it's a little bit cramped. I might space things out a tiny bit because the comments start to take up a lot of space at this stage. Now, before I relax, if you've got the luxury of having time to relax, potentially I would be doing maybe a final check if this is working, especially because of this harder logic in it. So let's just add back that checking line I deleted a while ago, just to see what it's doing at every stage of the process, just to be sure what we've done is correct, because I imagine you'd be doubting yourself at this point, maybe. Okay, right. Let's put this to one side so we can have a look at what's in the 2D list already. Look, there are no A's and B's in this list. So let's see, is it going to stop as soon as we hit the C? Because it should, according to our logic. So if I type in A, doesn't matter what the passcode is, it should, we've got our fingers crossed here, it should end as soon as it checks CAE 1110, which it does. Excellent. So what it's doing, it's realizing that, okay, right, A does not match up to CIE 1110. But also, A is less than CAE 1110. And so therefore it can't be in the list because all the opportunities to match have gone, right? If it's got to C, then it skipped all the A's, and so it can't be in the list. That is the slightly trickier logic that I was finding confusing earlier. And it is confusing. It's the sort of thing you've got to work out through trial and error unless it clicks straight away. Cool, I'm content that's working actually, so I'm going to delete this line of code. So that should be sufficient for question 6 being done. Now, what I'll be doing now, if you've got time, you should be going back through and personally, if you have got time, maybe you've got 10 minutes, half an hour maybe if you're really quick and really strong, I'll be going through, especially the questions you found hardest, and ideally ticking off whether you've got all of these points. These mouse freehand ticks here, not very good. Ticking off your points on paper, have you done all of these things? Have you definitely got a folder called completed coding which has all of these files in, and just maybe double check all of them are complete with what you did. You know, you might have made a mistake where you were editing the original files accidentally. Double check all of the 6 files you are submitting are what is asked for and are the code you are wanting to have submitted. So double check everything's missing. Quite possibly there would have been something, especially later on, you found hard and couldn't do or were confused about, and you decided to move on. Perfectly sensible. Just go back to it if you have time. Right, I would caution against going backwards and forwards so often. You know, if you skip a question the first time you encounter a tiny bug, that's probably not very helpful because you've kind of got to resume your thinking later on. It's better to try and debug on the fly. I mean, really, some people will find a lot of this paper quite easy, but some definitely won't. A lot of it is a mental battle, right? Of course, you've got to go in knowing Python fairly well, knowing this PLS document fairly well, being used to solving similar problems. But a lot of it is a mental battle. Are you mentally prepared to go in and find mistakes? Because every single person is going to have bugs. You know, I've been doing Python code for a very long time. I'm a strong Python programmer. I'll say that about myself. I had a few tricky bits, a few bits I found confusing. Everyone is going to go in and have bits which confuse them and are difficult, and everyone's going to have bugs, everyone's going to have errors, and it's a test whether you can keep cool under pressure, have confidence in your ability to fix it, and try and get as many marks as possible. It's out of 75. Some people are going to get 75 out of 75, but some people are doing paper 1. Dropping marks is perfectly fine. I hope I haven't, but you know, I might have spotted something and you might mention it in the comments. But ultimately, pick up as many marks as you can. Even in the trickiest question, question 6, I'm sure, we can have a look at the mark scheme, I'm sure there are marks given for adding comments, for asking for input, and so on. Let's have a look at their solution actually for the last question. First of all, so how similar is this to mine? Not very similar at all. So they didn't use a while loop for validation, which is fair enough. I stand by me using it. If you say ensure, that suggests you should use it. They used a while loop though for iterating through the list, which I think a for loop makes more sense, but they're not using break. They're using that Boolean toggle I showed briefly, which break can effectively replace, but fine, it should do the same job. I'm assuming this does the exact same as mine, maybe minus that validation. But if you look at how the marks are awarded, they're giving marks for solution design, good practices, and functionality. So it's not just what you're doing, it's also how well you're doing it. Are you decomposing it? Are you using the correct constructs? Are you, if we look sideways, are we using comments and so on? Is it readable, etc.? So pick up marks from doing simple things, even things like getting user input will get you marks. Not many, but it'll get you marks. So you should try every question, even if you're less confident with some of the topics. So hopefully this video was useful. If you've watched all of it, really well done. This is a really exciting paper to be doing. I enjoyed doing this video. I'd love to do this for real more times if I was 16 doing this paper, but I appreciate for many it will be stressful and a bit daunting, but I'm sure it will go really well, and I wish you the best of luck.